Okay, so in this phylogenetic tree of stars as species, um, it shows that at each named point, so we have um, the sun, or HD 32877, and then 3D 220507. So at named points like that, they represent a star, and it's like acting as a species in the phylogenetic tree. So we see that there are branches, and the lines that are connecting the stars, they all have different lengths, which are really important for showing the chemical distance between any of the two stars that is determined by adding up the lengths of the branches that are between them. So this ultimately means that the longer branches imply greater chemical distance, which ultimately means differences in chemical composition, or the more evolutionary change that is needed in this phylogenetic tree. So there are clades here that share more recent common ancestors. So the cluster of the red branches on the side represents a clade of stars that are more closely related to each other than the other stars on the tree, such as the black or the orange. And we can see that because obviously they're the same color, and there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's about 8 or 9 branch points there in which they spin off of each other, and you can see differences in the distances. So we can also see that there are numbers on the branches. So above the sun, we see a 4.5, and to the right of that, we see 3.5. And these numbers are the numbers that represent the chemical distance that the branch of the phylogenetic tree is. And if you were to sum up all of those numbers above the given colors, then you'd be able to get their total chemical distance. So we can see down low in that graph here that it's showing those are the times for the colors. Which they represent the estimated ages, or the time frame that are the common ancestors, or the formation of times between the populations in this phylogenetic tree between the stars. So we can see that a few things are happening here that we can infer. We can see that there are evolutionary relationships in this tree, that stars that are closer together on the tree with shorter branches lengths between them are to be more similar chemically, meaning that they are more closely related in their evolution to one another. We can see that the longer branches, they show that there are greater chemical divergence from their common ancestors, meaning the stars, and with that, we can see the clustering by origin of the trees that group the stars together with similar chemical compositions, which I had explained before. So here we have the red, and then we have the yellow, the black, and then the blue. And this one looks different than the trees that we've been seeing, but you can definitely still see with the different lengths and by their colors that they are indicated by. It shows a clear representation of how similar their chemical compositions are to one another and how closely they're related to one another.